Welcome to video lesson 2 of 2 for 10.5. For IM1, we have 3 boxes to talk about in this particular lesson. And the topic for this lesson is finding the distance between parallel lines. So let's dive right into this, okay? First, let's understand the basics. Finding the distance between any two parallel lines. What do we mean by that? Well, here's what we mean. Let's say we have two lines that are parallel. We know they are parallel because of the little red triangles. So let me zoom in there for you. We know these are parallel lines. So when we're talking about the distance between them, we're talking about the perpendicular distance between these lines. Now notice it can be anywhere, right? Since they're parallel, as long as it's perpendicular, this right here, this is the distance that we're talking about between those two lines. So that's what we're going to be learning how to find in this particular lesson today. Remember, it can be anywhere as long as it's perpendicular and we're looking for lines that are parallel. Okay, that's where we're going. Let's get to box 2. Okay, here is our first big working example. In box number 2, it wants us to find the distance between two parallel lines. So the two lines that they give us are y is equal to 1/2 x minus 2 and y is equal to 1/2 x plus 1. So if you can, it's always a good idea to sort of look at what these graphs look like on the page to give you an idea of what we're working with. So that's what we've got here. So here's the equation of 1/2 x plus 1. It's this blue line right here I'm highlighting for you. And then here's the other one, 1/2 x minus 2. So this one down here, okay? We're looking for the distance between these two lines. So we're going to choose to look for this distance right here. So it doesn't look very big. You know, looks like maybe just a little bit, just under 3 units maybe. I don't know. I'm just looking at it. It doesn't look that very big. So here are the steps. Step 1, it says find any equation of a line that is perpendicular to the two given lines, okay? So you have to start with the slope. So we know that the slope is 1/2 from each of the given information. So the slope that would be perpendicular would have to be a -2. All right, that's our first step, is find our slope of -2. And now that we have that, we could figure out the y-intercept of this equation. And it looks to me like the y-intercept is right down there at -2. So a line that we could use would be y is equal to, the slope is -2x, and the y-intercept is -2. So I can just look at that and find it, and you guys are welcome to do that too. When you're graphing these things, you can use a whiteboard and graph them out, okay? So that gives us this equation up here, -2x minus 2, that red line. That's step 1. Find any equation of the line that you can that's perpendicular. Step 2 is find both points of intersection. This is the really important part, okay? So we see down here that we can see where the red line and the blue line intersect at the point 0, -2, all right? What we want to do is figure out where do they intersect at this line right here. We want to find both points of intersection. So this point is easy to find. It's at 0, -2. We're interested in where this is equal to, these two lines are equal to each other. So the way that we do that is we set this line that we're looking for, 1/2 x plus 1, we set it equal to the red line to figure out where they're going to meet. So that's exactly what we're going to do right now. All right, so in this box, I'm going to set my new equation, which was y is equal to -2x minus 2, and my other equation, which is the one I'm looking for, 1/2 x plus 1, I'm going to set them equal to each other and solve for x. So I'm going to set -2x minus 2 equal to 1/2 x plus 1. I'm going to solve this for x, so I am going to subtract 1/2 from both sides. So -2 minus 1/2 is -2.5 x, minus 2 is equal to 1. So -2.5x is now equal to 3. So coming over here, x is equal to 3 divided by -2.5. Now, if you don't know what that is, you can totally use a calculator. That's fine. So 3 divided by, I'll do negative 2.5. Push enter, and you can push the math button and turn it into a fraction if you'd like. And that fraction is negative 6/5. So our x is negative 6/5, okay? Now that we know that, we have to plug it back in and get our y. So if I plug this negative 6/5 back into any of these equations, I would get a y value out. So I could plug it right over here, for example, and I would get y is equal to 1/2 times negative 6/5, and then add 1 to that. That would give me negative 6/10 plus 1. That's negative 6/10 plus 10/10. Sorry, it's kind of so small there. That would be 4/10, which is 2/5. Okay, so now if I erase this for you real quick here, you can see that that point of intersection is negative 6/5 comma 2/5. That's a lot of algebra to do for that one. So that's my point of intersection. Let's write it down over here. Negative 6/5 comma 2/5. Now, if you want to use decimals for that, you guys, you're totally welcome to use decimals as well. Okay, the last thing it wants us to do, step number 3, is just use the distance formula to figure out what that distance is between those 2 points. Okay, so our distance is going to be the square root. Remember our distance formula? X2 minus x1 squared plus y2 minus y1 squared, which is going to be, remember this is like your x1 and your y1, and the other point of 0 comma negative 2 is like your x2 and your y2. Okay, so we would have negative 6/5 minus 0 squared, and then plus y2, or y1, doesn't really matter. 2/5 minus negative 2, quantity squared. So that would give us a grand total of square roots of negative 6/5 squared. And then this is going to be plus 2/5 plus 10/5 quantity squared. That's just the number 2. All right, so from here, you want to plug this into your calculator because it's probably a lot to do. So bringing it up, I would do second square root, and then I would do in my parentheses. It doesn't matter if I put a negative 6/5 in there or a positive because it's going to be squared and turned to positive anyways. So I'll just do 6/5 and then quantity squared, and then plus, and then left parenthesis, we'll say 12/5 because 2 plus 10 is 12. So 12/5 and quantity squared, and hit our answer. So we're getting approximately 2.68. So if I round that, that'd be approximately 2.68, and this would be units. So that is definitely challenging because there are so many steps involved. But step 1 is find any equation of a line that's perpendicular. Step 2 is figure out where they intersect. And then step 3 is use that distance formula to complete the distance between the parallel lines. I realize that that's a lot, so if you have questions, please ask. All right, we'll do one more example. And again, same steps, right? So find the distance between y equals 2x minus 4 and y equals 2x plus 1. So I suggest that you graph these, and you can use the whiteboards to do that. So 2x minus 4, so just starting down at 4, 1, 2, 3, 4. So starting down here, we're going to go up 2 and over 1, up 2 over 1, up 2 over 1, up 2 and over 1. And then do your best to draw that line. So I'll draw my line like that. Do my best to draw that. Okay, there's my blue line. Okay, here's my red line. It says 2x plus 1, so starting at plus 1, so up 2 over 1, up 2 over 1, up 2 over 1, down 2 and over 1, so on and so forth, okay? So do your best to draw that line. And it looks like that. Okay, what we are interested in is the perpendicular distance between them. So I'll draw that for you like in green. So remember, we're looking for this distance, right, whatever it might be. I'll draw it right here for you, just to like draw it my best, okay? So we're looking for that right there. So what is this distance right here? All right. So it looks like this point is definitely a point that I could use, and that point would be 0, 1. So I'm going to keep that handy for myself in just a second. But it says, remember, step 1, find the equation of any perpendicular line. So for us, again, we know that the slope is 2 of the parallel lines that we're working with. So therefore, the slope that's perpendicular will be -1/2. And we can use this point at 0, 1. So the equation that we're going to have is y equals -1/2 x and then plus 1. So that is the equation of that little green line that I've drawn for you. Okay, find both points of intersection. So I want to know where the purple line right here is going to intersect my red one. So I'm going to set those two equal to each other. So and figure out where I'm looking for where it crosses right there. That's where that point is going to be. So I'm going to set the purple line, which is -1/2 x plus 1. I'm going to set it equal to the blue line. Sorry, I'm at the blue line. So that's going to be 2x minus 4, because I'm looking for where are they equal, where is that point right there, so I can find the distance between those. All right, so doing the algebra here for this one, I'm going to add a 1/2 x to both sides. So 1 is equal to 2.5x minus 4. I would add 4 to both sides. So in this one, I'll use decimals for you. So 5 is equal to 2.5x. So I'm going to divide by 2.5 on both sides, divide by 2.5 on both sides. So x is going to be 5 divided by 2.5 is exactly 2. So that shouldn't be a big deal for anybody. Again, if you need to use your calculator, go ahead, divide it by 2.5, and you get the same answer just in case you need it. Okay, then got to figure out what the y value is for the blue line. So I'm going to plug it right back in and start with y is equal to 2x minus 4. X is worth 2. So y is going to be 2 times 2 minus 4. Looks like y is 0. So we got kind of lucky with that one. Looks like this point over here is the point 2, 0. So there are my 2 points that I'm going to use in my distance formula. I'm going to use this guy as x1 and y1, and this guy as x2 and y2 for my distance formula. So my distance is the square root of x2 minus x1 squared plus y2 minus y1 squared. So that's just going to be 2 minus 0 quantity squared plus 0 minus 1 quantity squared. That's going to be the number 4 plus 1. That is just the square root of 5 is what that's looking like for us over there. Now, the other way you could do this, okay, and then again, sorry if I bring that in, so second square root of 5, right? That's about 2.23. So approximately 2.23. The other way you could do this is you could use the Pythagorean theorem like we did in our last unit and figure out the side lengths. That's 2 and that's 1, and that's our distance. So that, again, is just the square root of 1 squared plus 2 squared, which is your square root of 5. That will also work, so you can totally do that as well if you wanted to. Okay, again, really long problem, lots of places to make a mistake. Go nice and slow. Make sure you have those 3 points written down, the 3 steps there. And please come to me if you have any questions whatsoever. Okay, that's it for this lesson.